Hello friends, in today's project I'll be demonstrating an ionic motor. Ionic motor is not like the regular motor but works on the principle of ionization of air to produce thrust. Ionic motor works with extremely high voltages, plasma voltages of about 10 kilovolts. Ionic motor works on the principle of electrostatic forces. We know that if we have charged bodies, then it's either a repulsive force or an attractive force between these bodies. This is a conductor that has been taped to prevent coronal discharge from the sides. And rather, you have these sharp points, sharp brushes here, to rip off electrons from the air and cause the rotation. You also have a needle point here, okay, where it's rests on and spins freely. Alright, so let's get started. We have this container here. Let's connect the high voltage transformer to these two containers and let's see the reaction. There's an attractive reaction. Look at it. The two cars are attracting each other. See? Okay, so there is a force of attraction between these two cars. So one is actually positively charged, and that car is also negatively charged. So I'll introduce. So when we have charges, there is a field in between these containers. So we can demonstrate Franklin's bell with this. This ionic motor, you need the high voltage transformer. For me, I'm using a 3.7 3.7 lithium ion batteries, two of them in parallel, two 3.7 volts lithium ion batteries in parallel, and you have these points that rip off electrons from the air, and you have a charge point there. I will also be talking about the direction of this ionic motor. You can see these two. So to create a clockwise direction and to create an anti-clockwise direction, they must be opposite. So we're going to also talk about that. Okay, so I hang it into it. Okay. So I'm trying to spread my combs. Okay, this because it also works from principle of action of points and also a curved surface area. So you have a pointed point and also a curved surface. Right. So I'm going to connect and see it working. Okay, so it starts spinning immediately without even assisting it. Okay, so let's look at the direction. This is moving anti-clockwise direction to me. It's moving anti-clockwise direction. But if I wanted to move clockwise, I have to change the direction of those points. So that's what I'm going to do right now. So I'm going to change the direction of points, and it should be able to spin this way. Let me spread the brushes, which is used in ionizing the air, and put it back. Okay, to spin freely. Okay. Okay, so it's spinning freely, but we can see it going in the clockwise direction. Okay, because the direction has changed. Okay, so once we change the direction, it's going to spin the other way. The direction of this point is going to spin the other way. Alright, so it's not clockwise. So how does this motor actually work? Here, there are neutral air molecules here, so it works by ionization. This motor works by ionization of air molecules. There are neutral air molecules here, and this point, this wire is connected to this needle, which connects to these points. This point reads electrons from the oxygen and nitrogen molecules and leaving them positive charge. So we have a positive charge cloud of ions here, and because these points are also positively charged, there will be a repulsion. That repulsion makes it spin this way, makes it spin clockwise, while the wind is towards this direction. So you can actually predict the direction of this motor. Okay. The terminals, changing the terminals won't even matter, but the direction of these points is what actually matter for the direction of these motors. Okay. Alright, so I'm going to change this and introduce one with 4 points. Let's say 4 points. Okay, so it works for these 4 points. Alright, so that's the end of today's project, but let me attach this one once again. Let's take note of something. See, the motor increases in speed, but yes, when it is further, it still works. Thank you for watching this project.